Today we're going to continue looking at section 3.7. So that means we are going to apply theorems relating the angle measures and the side lengths of triangles. So let's go ahead and take a look at this algebra problem. So I would suggest that you sketch the picture. We are given that triangle ABC is isosceles with the base BC. So remember, anytime we have an isosceles triangle, that means that we have at least two sides congruent. With the base being identified, that means that the other two sides are the legs, and it's the legs that are congruent in our triangle. So BC being the base means that AB and AC are congruent because those are the legs. And so I can deal with the fact that if those two sides are congruent, well, then I can make an equation where those two segments are equal, because congruent means equal. And then because I know that those two sides are congruent, remember our theorem that if the two sides are congruent, then the angles directly opposite them are congruent. So that means that this angle B and this angle C are congruent. And so congruent means equals. So I can set up a second equation where I set those two things equal. And so I needed to have two equations because I have both an x and a y. We had to set up a system. So what I'm going to do is I'm going to rearrange these equations to get them into an elimination form. So I want all the x's and the y's to one side, and I want the numbers to the other. So what I'm going to do is I'm going to subtract the 4y over to the left so I can have x's and y's. So then that 6 has to get moved over to the right, so I'm going to subtract that. In the bottom equation, I'm going to subtract the 5x to move that over to the left, and then everything else seems to be in place. So top equation, I'm going to then have 7x minus 4y, and that's going to equal, well, 55 minus 6 is going to be 49. So there's my top equation. The bottom equation, I'm going to have 3 minus 5 to give me a negative 2x. I'll have minus y, and that's going to equal 1. All right, so I have my format set up, but now I have to look to see, can I eliminate anything? Well, 7 and negative 2 are not going to make those x's eliminate. Negative 4 and negative 1, same idea. They're not going to eliminate to 0. However, I can take that bottom equation and I can very easily turn that negative 1 into a positive 4, so then I can get rid of the y's. I'm going to multiply the entire bottom equation by negative 4. So the top equation never changed, so that's still 7x minus 4y equals 49. In the bottom equation now, if I multiply everything by negative 4, I'll have positive 8x plus 4y, and that's going to equal negative 4. So now I can add up these equations because notice that the y's are going to cancel. 7x plus 8x is 15x, and 49 minus 4 is 45. I'll divide both sides by 15, and that will give me x to be 3. Because they want me to find the measure of angle A, which doesn't have an expression, and they want me to find the side of AC, which deals with a variable of y, I have x, I'm going to go and solve for y as well. So I can go back to really any of the equations in order to then substitute the 3 in. So I think I'm going to go back to the equation where I have 7x minus 4y equals 49. So I'm going to have 7 times 3 minus 4y equals 49. So I'll have 21 minus 4y equals 49. I'll subtract 21 from both sides. That'll give me a negative 4y to equal 28. And then when I divide both sides by negative 4, I'll get y to be negative 7. All right. So now that I have both x and the y, I can find what I'm asking for. So if I want the measure of angle A, we have to understand that 3 angles of a triangle add up to 180. So what I'm going to do is I'm going to find the measure of angle B, I'm going to find the measure of angle C, and then that's going to help me get the measure of angle A. So angle B, we're going to have 3 times 3 minus negative 7. Well, 3 times 3 is 9. When I subtract a negative, it's going to turn to addition. So that's going to give me a 16-degree angle. And so that's also going to be the answer over here. It's going to be 5 times 3, which is 15. When I add 1, I get 16. So to find my answer for the measure of angle A, I'm going to take 180 minus 16 minus 16. So 180 minus 16 tells me that the answer to the angle that I'm looking for is an 148-degree angle. So there's one of my answers. Now I want to find the length of AC. Well, I just needed y in order to do that. So 4 times -7 plus 55. Well, 4 times -7 is -28. When I add 55 onto it, looks like that length is 27. And remember, I don't put a degree symbol because when we're talking length of a segment, it's not measured in degrees. And there are my answers. All right, if I want to find both x and y, looking at this picture, x and y are being represented as angles. And in this problem, because two sides are congruent, then the angles directly across from them are congruent. So that looks like those two angles are congruent. So one equation is that x equals 9y. Because there are two variables, we have to come up with a second equation. The only information that I really know based off this picture is the fact that I have a right angle and I've got the two other angles that are marked. So 3 angles of a triangle add up to 180. So I know that x plus 9y plus 90 is going to equal 180. All right. So this problem is actually already set up for us. We can do substitution. Because I know that x equals 9y, I can plug the 9y into that bottom equation for x. So really, 9y plus 9y plus 90 equals 180, and that's how I can solve for y. So combine like terms, that's 18y plus 90 equals 180. I'm going to subtract the 90 from both sides. That gives me 18y to equal 90. And so 90 gets divided by 18. And so I have half of my answer, y equals 5. But I also need to solve for x. That takes us back to that top equation. If I know that x equals 9y, I know that x equals 9 times 5. Well, 9 times 5 is 45. So there's my other answer. All right, sketch this picture and then we can go ahead and solve this proof. So let's start with the fact that we are given the angle ASD is congruent to the angle BSC. And I'm going to mark that in my picture, so follow the letters carefully. ASD is this angle. BSC is this angle. I can't expand on that any further, so my next given is that S is the midpoint of the segment DC. But that is something that I can expand on. So if I have a midpoint, that means that it's dividing a segment into two congruent segments. So that looks like that's the segment DS and the segment CS. Okay, notice how I have to put the D and the C in the same spot, because if you look at even like my first given, the S's are in the same spot, the D and the C are in the same spot for those angles, so I need to make sure I'm consistent. So why do I know that they're congruent? Well, if a point is a midpoint, then it divides a segment into two congruent segments. And then I can mark my picture. Okay, we have one other given. We are told that angle SAB is congruent to the angle SBA. So if we follow the letters, SAB is this angle, SBA is this angle. Okay, I can't expand on that any further. So looking at what we're trying to prove that the triangle SDA, which is this triangle right here, is congruent to the triangle of SCB. So looking at the two triangles that I just highlighted, they already have two things marked. I just need one more thing in order to make that happen. So the question is, why did I give us angles that are outside of the triangle? Well, if we look at the two angles, SAB and SBA, they're in a triangle of SAB. And if I have two triangles or two angles in a triangle that are congruent, then remember the sides opposite those angles are congruent. Notice the side opposite the angle SAB is the side SB, and that's in the triangle that I'm trying to prove congruent. Notice that the side across from angle SBA is the side of SA. That's a side in the triangle that I'm trying to prove congruent. So I'm able to say that those two sides are congruent. So side SA is congruent to the side SB. And remember, that's because we started with one triangle of SAB. And so if that triangle has angles that are congruent, then I know that the sides directly across from them are congruent. And now that I have 3 markings in my triangles, notice that I do have the correct set of markings for me to then be able to prove what I'm asking. So I can prove that the triangle SDA is congruent to the triangle of SCB, and that is because of side, angle, side. So if I go back through my proof, it looks like the first set of congruent sides came from step number 3. Notice that the angles that were inside the triangles came from step number 1, and then step number 5 got us our other congruent sides. Okay, please sketch this picture. All right, so let's write down our first given. We know that angle ADC is congruent to the angle DAC. So I'm going to mark that carefully. So ADC, that is this angle, is congruent to angle DAC. That's this angle. All right. Moving on to my other given, I am told that angle CAB is congruent to the angle CDE. So following the letters, CAB is this angle. Angle CDE is this angle. All right. Notice that we are trying to prove that angle B is congruent to angle E. So there are quite a few triangles in this picture. We have to figure out what triangles are going to benefit us here. And there's actually several different options for us to prove that we can, at the end, get angle B and angle E congruent, because there are angles that are inside actually 2 different triangles. So several different ways here. I think the triangles that I might want to focus on is the triangle of DCE and the triangle of ACB. Okay, so if I want to focus on those two, right now I have one thing marked. Okay, I need to get 3 things marked to state that those triangles are congruent. And then once I have congruent triangles, any other parts of those triangles are congruent. So once again, why did they give us angles in a triangle that I'm not actually using? Well, because that triangle of DCA has 2 angles congruent, if the angles are congruent, then the sides across from them are congruent. So it looks like the sides across from those would be the side DC and the side AC. So I can say that those two are congruent because, once again, it has to be one triangle, but we started with 2 angles, and if those angles of the triangle are congruent, then I know that the 2 sides are congruent. And then I can mark that. So now I have 2 things that are marked in those highlighted triangles. Hopefully we notice that those 2 triangles happen to have angles that share a vertex and are directly across from each other. So that means that angle ECD is congruent to the angle of BCA, and that's because vertical angles are congruent. So I can mark this angle congruent to that angle. Notice that I have now 3 things that are marked inside the triangles that I highlighted. So I can say that the triangle ECD is congruent to the triangle BCA. And if you look at the markings, that's because of angle, side, angle. So the first set of angles that are in the triangles I'm trying to prove congruence, that didn't come until let's see, ADC. Okay, so step number 1 does not have the angles I'm looking for. It was step number 2. That was the first set of angles within my triangle. Then I want my sides. Well, that came from step number 3. And then step number 4 gave me my other set of congruent sides, or angles, I mean. But now that I have 3 things that are marked, I got my congruent triangles. Any other pieces are congruent. So I can say that angle B is congruent to angle E. And remember, that's because corresponding parts of congruent triangles are congruent. So that's us applying theorems relating the angle measures and the side lengths of